During the 2024 edition of the World Economic Forum, several sessions of the REACH conference program were dedicated to AI, in particular to the impact on society, the need for inclusion, risks and opportunities, and future advancements. Less than a month later, some of the same topics take center stage in Dubai during the World Government Summit, an event that is often referred to as the Davos of the desert. This time the speaker is the man that, with his company, is leading the AI revolution, NVIDIA CEO Jensen Huang. The title of the session was "Who Will Shape the Future of AI?" and, in our opinion, the subtitle could have been "Tech Companies or the Governments." And this is because to ask questions to Jensen Huang was a representative of the government of the host country, His Excellency Omar Al-Olama. The host was also at Davos for the World Economic Forum the previous month, but on that occasion he was a panelist among other tech leaders. The reason is that he also holds a leading role in artificial intelligence. Omar Al-Olama is the Minister of State for Artificial Intelligence. The United Arab Emirates established the position in 2017, and so far it is the only country with a dedicated Minister of AI. We were expecting a session with an optimistic outlook on AI, as Omar Al-Olama was very positive also during his comments at the World Economic Forum in Davos, and we were right. The discussion, in fact, can be summarized in the following main topics: how governments should address AI, the risks of have and have not among companies, what would be the first step to take for countries with low GDP, how to address the fear of AI, what's next for GPUs, and path to take in education in AI.
Well, first of all, these are amazing times. These are amazing times because we're at the beginning of a new industrial revolution. Production of energy through steam, production of electricity, IT and information revolution with PC and internet, and then now artificial intelligence. We are experiencing two simultaneous transitions. And this has never happened before. The first transition is the end of general purpose computing and the beginning of accelerated computing. It's like specialized computing. Using CPUs for computation as the foundation of everything we do is no longer possible. And the reason for that is because it's been 60 years. We invented central processing units in 1964, the announcement of the IBM System 360. We've been riding that wave for literally 60 years now. And this is now the beginning of accelerated computing. If you want sustainable computing, energy efficient computing, high performance computing, cost-effective computing, you can no longer do it with general purpose computing. You need specialized domain specific acceleration. And that's what's driving at the foundation our growth, accelerated computing. It's the most sustainable way of doing computing going forward. It's the most energy efficient. It is so energy efficient, it's so cost effective, it's so performant that it enabled a new type of application called AI. The question is, what's the cart and the horse? You know, at first it's accelerated computing and enabled a new application. There's a whole bunch of applications that are accelerated today. And so now we're in the beginning of this new era. And what's going to happen is there's about $1 trillion worth of installed base of data centers around the world. And over the course of the next 4 or 5 years, we'll have $2 trillion worth of data centers that will be powering software around the world. And all of it's going to be accelerated. And this architecture for accelerated computing is ideal for this next generation of software called generative AI. And so that's really at the core of what is happening. While we're replacing the installed base of general purpose computing, remember that the performance of the architecture is going to be improving at the same time. So you can't assume just that you will buy more computers. You have to also assume that the computers are going to become faster. And therefore, the total amount that you need is not going to be as much. Otherwise, the mathematics, if you just assume, that computers never get any faster, you might come to the conclusion we need 14 different planets and 3 different galaxies and four more suns and to fuel all this. But obviously, computer architecture continues to advance. In the last 10 years, one of the greatest contributions, and I really appreciate you mentioning that, the rate of innovation, one of the greatest contributions we made was advancing computing and advancing AI by 1 million times in the last 10 years. And so whatever demand that you think is going to power the world, you have to consider the fact that it is also going to do it 1 million times larger, faster, more efficiently. First of all, when something improves by 1 million times and the cost or the space or the energy that it consumed did not grow up by 1 million times, in fact, you've democratized the technology. Researchers all over the world would tell you that NVIDIA single-handedly democratized high-performance computing. We put it in the hands of every researcher. It is the reason why AI researchers, Jeff Hinton in University of Toronto, Yann LeCun, I think Yann's going to be here, University of New York, Andrew Ng in Stanford, simultaneously discovered us. They didn't discover us because of supercomputers. They discovered us because of gaming GPUs that they used for deep learning. We put accelerated computing or high-performance computing in the hands of every single researcher in the world. And so when we accelerate the rate of innovation, we're democratizing the technology. The cost of building, purchasing a supercomputer today, it's really negligible. And the reason for that is because we're making it faster and faster and faster. Whatever performance you need costs a lot less today than it used to. It is absolutely true we have to democratize this technology, and the reason why is very clear. There's an awakening of every single country in probably the last 6 months that artificial intelligence is a technology you can't be mystified by. You cannot be terrified by it. You have to find a way to activate yourself to take advantage of it. And the reason for that is because this is the beginning of a new industrial revolution, and this industrial revolution is about the production not of energy, not of food, but the production of intelligence. And every country needs to own the production of their own intelligence, which is the reason why there's this idea called sovereign AI. You own your own data. Nobody owns it. Your country owns the data. It codifies your culture, your society's intelligence, your common sense, your history. You own your own data. You therefore must take that data, refine that data, and own your own national intelligence. You cannot allow that to be done by other people. And that is a realization. Now that we've democratized the computation of AI, the infrastructure of AI, the rest of it is really up to you to take initiative, activate your industry, build the infrastructure as fast as you can so that the researchers, the companies, your governments can take advantage of this infrastructure to go and create your own AI. The first thing you have to do is you have to build infrastructure. If you want to mobilize the production of food, you have to build farms. If you want to mobilize the production of energy, you have to build AC generators. If you want to operationalize if you want to digitalize your economy, you have to build the internet. If you want to automate the creation of artificial intelligence, you have to build the infrastructure. It is not that costly. It is also not that hard. Companies all around the world, of course, wants to mystify, terrify, glorify, all of those ideas. But the fact of the matter is, they're computers. You can buy them off the shelf. You can install it. Every country already has the expertise to do this, and you surely need to have the imperative to go activate that. The first thing that I would do, of course, is I would codify the language, the data of your culture into your own large language model. And you're doing that here. Core 42, Saudi Aramco, Sadai, really doing important work to codify the Arabic language and creating your own large language model. But simultaneously, remember that AI is not just about language. AI, we're seeing several AI revolutions happening at the same time. AI for language, AI for biology, learning the language of proteins and chemicals, AI for physical sciences, learning the AI of climate, materials, energy discovery, AI of IoT, the language of keeping places safe, computer vision and such, AI for IoT, AI for robotics and autonomous systems, manufacturing and such. There's AI revolutions happening, AI great breakthroughs happening in all of these different domains. And if you build the infrastructure, you will activate the researchers in every one of these domains. Without the internet, how can you be digital? Without farms, how can you produce food? Without an AI infrastructure, how can you activate all of the researchers that are in your region to go and create the AI models? First of all, whatever new incredible technology is being created, you go back to the earliest of times, it is absolutely true. We have to develop the technology safely, we have to apply the technology safely, and we have to help people use the technology safely. And so whether it's the plane that I came in, cars, manufacturing systems, medicine, all of these different industries are heavily regulated today. Those regulations have to be extended, augmented to consider artificial intelligence. Artificial intelligence will come to us through products and services. It is the automation of intelligence, and it will be augmented on top of all of these various industries. Now, it is the case that there are some interests to scare people about this new technology, to mystify this technology, to encourage other people to not do anything about that technology and rely on them to do it. And I think that that's a mistake. We want to democratize this technology. Let's face it, the single most important thing that has happened last year, if you were to ask me, the one single most important event last year and how it has activated AI researchers here in this region, it's actually Llama 2. It's an open source model.
Or Falcon.
Or Falcon, another excellent model, very true. Mistral, excellent model. I just saw another one, a Smog. There's so many open source models, innovations on safety, alignment, guardrailing, reinforcement learning, so many different reasoning, so many different innovations that are happening on top of transparencies, explainabilities, all of this technology that has to be built, all were possible because of some of these open source languages. And so I think that democratizing, activating every region, activating every country to join the AI advance is probably one of the most important things, rather than convincing everybody it's too complicated, it's too dangerous, it's too mystical, and only 2 or 3 people in the world should be able to do that. That, I think, is a huge mistake. You know that in just about all of the large companies in the world, there are internal developments. At Google, there's TPUs. At AWS, there's Trainium. At Microsoft, there's Maya. Meta has chips that they're building. In China, just about every single CSP has chips that they're building. The reason why you mention NVIDIA GPUs is NVIDIA GPU is the only platform that's available to everybody on any platform. That's actually the observation. It's not that we're the only platform that's being used. We're simply the only platform that's used that democratizes AI for everybody's platform. We're in every single cloud. We're in every single data center. We're available in the cloud, in your private data centers, all the way out to the edge, all the way out to autonomous systems, robotics, and self-driving cars. One single architecture spans all of that. That's what makes NVIDIA unique. that we can, in the beginning when CNNs were popular, we were the right architecture because we were programmable. Our CUDA architecture has the ability to adapt to any architecture that comes along. So when CNN came along, RNN came along, LSTMs came along, and then eventually transformers came along, and now vision transformers, bird's eye view transformers, all kinds of different transformers are being created. A next generation state space models, which is probably the next generation of transformers. All of these different architectures can live and breathe and be created on NVIDIA's flexible architecture. And because it's available literally everywhere, any researcher can get access to NVIDIA GPUs and invent the next generation. I'm going to say something, and it's going to sound completely opposite of what people feel. You probably recall, over the course of the last 10 years, 15 years, almost everybody who sits on a stage like this would tell you it is vital that your children learn computer science. Everybody should learn how to program. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program. And that the programming language is human. Everybody in the world is now a programmer. This is the miracle. This is the miracle of artificial intelligence. For the very first time, we have closed the gap. The technology divide has been completely closed. And it's the reason why so many people can engage artificial intelligence. It is the reason why every single government, every single industrial conference, every single company is talking about artificial intelligence today. Because for the very first time, you can imagine everybody in your company being a technologist. And so this is a tremendous time for all of you to realize that the technology divide has been closed. Or another way to say it, the technology leadership of other countries has now been reset. The countries, the people that understand how to solve a domain problem in digital biology or in education of young people or in manufacturing or in farming, those people who understand domain expertise now can utilize technology that is readily available to you. You now have a computer that will do what you tell it to do, to help automate your work, to amplify your productivity, to make you more efficient. And so I think that this is just a tremendous time. The impact, of course, is great, and your imperative to activate and take advantage of the technology is absolutely immediate, and also to realize that to engage AI is a lot easier now than at any time in the history of computing. It is vital that we upskill everyone, and the upskilling process, I believe, will be delightful, surprising, to realize that this computer can perform all these things that you're instructing it to do and doing it so easily.
So if I was going to choose a major in university as a degree that I'm going to pursue, what would you give me as advice for something to pursue?
If I were starting all over again, I would realize one thing, that one of the most complex fields of science is the understanding of biology, human biology. Not only is it complicated because it's so diverse, so complicated, so hard to understand, living and breathing, it is also incredibly impactful. Complicated technology, complicated science, incredibly impactful. For the very first time, and remember, we call this field life sciences. And we call drug discovery, as if you wander around the universe and all of a sudden, hey, look what I discovered. Nobody in computer science, nobody in computers, and nobody in the traditional industries that are very large today, nobody says car discovery. We don't say computer discovery. We don't say software discovery. We don't go home and say, hey, honey, look what I found today. This piece of software. We call it engineering. And every single year, our science, our computer science, our software becomes better and better than the year before. Every single year, our chips get better. Every single year, our infrastructure gets better. However, life sciences is sporadic. If I were to do it over again right now, I would realize that the technology to turn life science to life engineering is upon us. And that digital biology will be a field of engineering, not a field of science. It will continue to have science, of course, but not a field just of science in the future. And so I hope that this is going to start a whole generation of people who enjoy working with proteins and chemicals and enzymes and materials, and they're engineering these amazing things that are more energy efficient, that are lighter weight, that are stronger, that are more sustainable. All of these inventions in the future are going to be part of engineering, not scientific discovery.
And in terms of education, let's listen to what the United Arab Emirates are doing under the guidance of the Ministry of AI. Once again, the comments are from the World Economic Forum in Davos.
I think the only constant is change. And we need to build a populace that is able to adapt to change, that's able to embrace technologies, and that's able to also always be agile and have a robust set of skill sets and be curious about the future. What we did in the UAE, so just quickly to touch upon some of the things that we did. The first is to combat ignorance in the government. We launched a program with the University of Oxford where we train senior government officials to understand what artificial intelligence is, what ethics of AI are, how do you use it responsibly, what is good and bad use cases as well. We have over 400 officials across the government of the UAE that have graduated from this program that are today leading the charge. So, we have more awareness in the government. We launched another program, which is on the 29th of October of every year. We have a day that we celebrate technology and coding and AI and all these tools. So we said there are two ways for us to teach people about artificial intelligence. Either do a pull approach, tell them come to this hall and we do a seminar on artificial intelligence, or to do a push approach. So on that day, every single person in the UAE gets an SMS on their phone that says technology and artificial intelligence is the future. Start your journey to understand what the future is and how you can play a role in it. Click the link. They click the link, they write a line of code, and they understand how easy it is, and then they can create a journey towards actually learning what artificial intelligence is, how it's impacting their lives, if they're going to be an architect, a doctor, even just a normal citizen, what AI is going to do for them. And over 180,000 people in a country that is not very big have actually gone through that journey. And the numbers are just snowballing into bigger numbers. The final thing we did was we actually deployed AI education within our schooling. So from grade 5 onwards, people learn how to code. From grade 9 onwards, kids in schools actually learn what artificial intelligence is, what are the ethics of it, and they also understand whatever their career path is going to be, how AI is going to affect it.
Wow. Senator, what do you think? SMSs to every citizen of the United States?
Look, what they're doing is phenomenal, and they're in a position to be able to do it very, very rapidly. We can't do that.